I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. Now, the shear clamp for this boat is a complicated timber. Temptress has got quite a lot of shape to her top sides. She's got quite a lot of tumble home aft and some flare in the bow towards the forward end of the boat. That consequently means that the shear clamp, which runs along the transition of the side of the boat to the deck of the boat, is a complex timber to make. It's got a lot of shape to it. It twists down the entire length of the boat. It's got curvature in the plan view, of course, as the timber turns in to meet the bow of the boat, but it's also got curvature in profile as it follows the curvature of the deck. So that makes it a very challenging timber to form. I did this one way using small square section timbers when I did the model, but I've actually come up with a CNC cut solution that makes this timber much easier to shape and a lot easier to get fair. So let's take a look at how this runs through the boat and how we actually form this timber. So this is the area of the boat in which our timber is going to run through. Now we've got two ways that we can approach this. We can either orient the timber in this way, so we can align it with our outer hull side planking, and then we can trim the top face along here to the profile of our deck line, which gives us a timber looking something like that. Or we can do this perpendicular to our deck line, and then we can trim it on this face here to match the side of our hull side planking. Now what we're really aiming to achieve from this timber is to have a uniform glue surface area across the deck line, so across this edge here, and then a uniform surface down here for the hull side planking, because we're landing the two of those onto this timber. And the way that we arrange this timber can obviously vary greatly throughout the boat. We've got quite a flare to the top sides here up at frame 4, but then as we get back and that changes to tumble home as it comes in from the transom, the timber's doing something very different. And as that moves throughout the boat, by keeping these two faces at a uniform width here, that can actually change the dimension of this timber quite greatly as it moves back through the transom. Now with the original timber, we made it perpendicular to the outside planking, so it was in this direction, and as you can see immediately with that timber, that puts it at quite an angle, and that means that as this comes through the boat back aft, there's quite a lot of twist to it, and it means that it's also trying to edge set, so it's trying to bend upwards against its longest face. So whilst that's doable, that makes it quite a difficult timber to do, and that's the reason that on the model I did this out of 4 small square section timbers, because they will handle the twist and the edge set nice and evenly. Now what we've done is Michelle's actually reworked the design of this shear clamp to follow the deck and be perpendicular to that instead of to the side. The main reason for that is that there is far less curvature to the deck profile than there is to the hull side profile, which takes a lot of the twist out of that timber. It means that it's a slightly different shape and a different orientation, but it makes it much more easy to form. Coupled with that, I've also come up with a CNC solution to actually cut one of those curved planes into the timber and form it in that way. So in order to start creating this timber and show you how it looks, the first thing I need to do is to machine some stock and then cut it on the CNC machine. So let's get cracking with that. Okay, so this is the stack of parts for the shear clamp. So we've got 3 layers to the lamination. So we've got A, B and C. Then we haven't, 1, 2 and 3, sorry. And then they are A to E down the length of the boat. And they join together within each part within this CNC cut scarf joint. Now these parts are oriented so that we've got minimal grain run out, because obviously we're creating quite a large curve in the plan form here, and we don't want to have short grain in the parts. So I've tried to minimize that as much as possible. And the way that this joint is actually oriented, it creates a crossover of grain directions in the area of each of these components where the grain run out tends to get worse. So if we look at this part here, for example, you can see that this grain run out is starting to get worse towards the tip of the part. So this is going to be where the wood starts to get weakest. But then due to the nature of the joint that I've used for this particular application, you can see that as we place these 2 parts together, we've got that kind of reinforced and then remedied by the next piece of timber that comes along. And then of course we've also got a lamination on the top side and the bottom side, which is going to completely overlap this scarf joint anyway. So we've got a huge amount of reinforcement within that part. So we've got 3 layers to the shear clamp. We've got 5 pieces longitudinally per layer. So the next thing to do is to get all of these scarf joints assembled so that each of these packs is one long piece of timber. So let's get some West System epoxy glued up and we'll get assembling them. This freaking thing's massive. Jesus Christ. Right. Let's try. Okay, if you are a regular viewer of the channel, then you will have seen quite a lot of the actions going on within my workshop. And anybody that has watched the YouTube channel and then actually visited my workshop all say exactly the same thing. It's a lot smaller than it looks on camera. Well, Temptress, by the standards of what I do, is a big boat and my workshop is not. So let's take a look at how the scale of things are actually going to work when it comes to setting this boat up in here. So to give you a little bit of an idea, here are the shear clamp blanks that I'm just about to try and get through my sander. That sander is as absolutely far as I can get it that way within the workshop, and these are running right over into the corner of the shop. Bear in mind, I've also got to get those out the other end, which is going to have to be through the open doors, and I'm going to have to try and steer the shear clamps out through there. So that's going to be a bit of a task. This is one of the reasons that I cleaned up the stringer by hand and not through the machine. There's no way I could have wielded that stringer through this machine. So when it comes to setting Temptress up, we're going to have to do a bit of reorganization here. This bench is probably going to go or be significantly downsized. The Healy and the Stapley are both going in January. So that means that I'm going to have as much free space as I can, and that's when we're going to start setup of the boat. So that's going to be a really nice phase to get to. The boat scale wise, this Healy I think is 16 feet and Temptress is 24, but with the width and the general scale of the boat, it is big by comparison. So we're probably going to have to take this bench back and move that back out the way, because the gap between these posts here is probably, I don't know, 9 foot, something like that, and Temptress is like 7'10", so it's almost going to be, you know, it's going to fill this space here. So we'll see plenty of examples of comparisons of scale for this, but right now I'm going to try and get these shear clamp timbers through the sanding machine to bring them down to their final thickness dimension. We'll see how that goes. So there is a look at the finished shear clamp arrangement. So you can see that our parts join with these little scarf joints here to reduce our run out of grain as we turn the corner, and then you can see that our curvature in the plan form is actually cut into this timber already. So that means that we've got no stress to inducing this timber as we curve it inwards towards the bow. And we've got some minimal curvature to do in this direction from the side. So that is just going to follow the curvature of the deck, and it's going to slightly roll off towards the transom, almost very much like you can see it just hanging off the tail of my table saw there as it curves down. So the idea is that these three laminates will slip over each other, and we'll bond those together using the boat as a form, which will form the curvature in this direction, which is the slightest of the curvatures. So that'll curve to follow the form of the boat. And then to form the actual shape of the side of the boat, this is done quite cleverly with stepped layers between each part. So what we do is we align this timber on its inner face. So all three of these layers are lined up using their inner face as a common reference. And then the outer face is shaped in a stepped format, which indicates the bevel that needs to be cut to follow the side planking. So you can see that that starts equal up forward there, where the three layers are the same, and they kind of part ways and they step out along this section of the timber here, where we've got really big flare in the top side. So this is the deck side of the timber. And when we join those lines together, we're going to form that angle to the side of the boat. And then as we come back down aft, you can see how that curvature changes. We get to the middle of the boat and it almost kind of flattens out again as we get to frames that have got vertical sides to them. And then it actually goes the other way as we get back down aft and then comes back inwards, and this is where our tumble home is going to be back on the transom, so this indicates our tumble home angle. So you can see that we've already got the shape of the boat in the shear clamp there, and once we've laminated the curvature and the profile, this is going to allow us to actually entirely shape the shear clamp off the boat. And being able to make this timber off the boat means that you can get it really nicely fair, because you've got this curvature already cut in. You've got no stressing of the timber to do, so you haven't got to try and form that. You're actually going to use this as your guidance to then mark and cut your notches in your framing on the boat. And probably the best thing of all is that you can make yourself a guaranteed matched symmetrical pair of shear clamps, so both sides of your boat are going to be perfectly symmetrical. And that is a lot more rare than you would actually think within wooden boats. It's very often that things are not the same on both sides. So this is going to greatly help with that. Now when it comes to actually shaping the bevel on this, the kind of bevel that rolls from inwards to vertical to an undercut bevel, we're going to use these steps within the layers that are taken from within the CAD model and then CNC cut, and we'll turn them into one complete rolling bevel. And I've got a little piece of timber mocked up, so I'll just show you how we're going to do that. Okay, so this little timber mock-up represents much the same as what we're seeing on the shear clamp. So we've got steps between our layers of laminations and they vary from one end to the other. Now in order to turn this into the true bevel, basically what we're going to do is just join up all the lines and form the shape that runs through there. This is on obviously much more condensed and smaller scale. But we'll be using a hand plane to do this, so I'll demonstrate on this small section of timber. Okay, so that's a rough illustration of the principle that we're going to be adopting with this shear clamp. Now you can see that as we plane this down, as we start to lose these little steps, that indicates that we're at our correct bevel angle. Obviously this is on a very condensed timber and we've got a fair amount of angle change over quite a short period there. This is going to be a much more steady transition throughout the length of the shear clamp, but you can see that that's how we'll roughly take that from a stepped to a continuously beveled timber. So that's the process of creating a complex, twisted and curved timber utilizing CNC. That has not only taken out one of the greatest curves that we've got to normally spring in with this timber, but it's also given us this stepped, incremented guidance, which is going to help us to roll that continual bevel all the way throughout the shear clamp throughout the boat. And that means that we can do pretty much all of this shaping once it's laminated off the boat, and we can just drop the shear clamp in and use that as our guidance for cutting the notches through the framing and get us a really good fair timber all the way through. So if you're building one of these boats and you've got a set of the plans, then by all means drop me a message and I'll send you the files for the latest shear clamp bits if you wish to use this method. So thank you for watching, and an extra special thank you to all my patrons that are helping me to fund this project with a little extra monthly pledge. I greatly appreciate it, guys. It really helps me to move this project forward. So cheers guys, I'll catch you in the next one.